There we go. Okay. All right. And of course, again, chat in, raise your hand if you have anything you want to add or ask questions about. Going into section 3 here. The first couple sections were rather longer, and as we get towards the end of this chapter, they get progressively quicker. So the naming system for ions, whether they are monatomic or polyatomic, is fairly complicated. But once you know the names of the ions, once you know the names of all the eights, the sulfates, the phosphates, the carbonates, then it's rather straightforward. Naming molecular compounds at first is a little simpler, but as you go down the road, they have a whole year of it in college if you go into chemistry called organic chemistry, which just focuses on like the names and reactions of the carbon compounds. And so it does get more complicated than what's just in this section. But I want you to know that that we're going to look at that, and it won't, on this level, it won't be quite as big as, good morning. It won't be quite as big as it could be. It won't be quite as big as the ionic naming even was. All right, everyone there? All right. Okay. All right. So we have prefixes, words that are fixed or attached to the other words, that will tell us what numbers we have. So we use Greek and Latin prefixes. So tri means 3, right? You can kind of see the word tree in there, right? This is one of those prefixes, by the way, that shows us how related languages all the way from England to India are, at least the ancient Sanskrit. So, what guideline? And by the way, you never have this in a triathlon. Which event is this you see pictured? This one they're not going to jump. Say again. Yeah, what are you going to say? Javelin. Yep, they throw it right. And so you might see that in the pentathlon or heptathlon or decathlon. All those prefixes you learned in math class years ago, right? Must be the UPS plane. Anyway, not the triathlon. What events do you have in the actual triathlon? Swimming, biking, and running. Yes, in that order, too. So you know your sports. And why don't they put swimming at the end? Yeah, I mean, if you're gonna run out of energy, you want to do it when you're running and just fall down to the ground. You might get a scrape or two, no big deal. But if you you know, if you fall down in the water, then you're in big trouble. Yeah. So the reverse triathlon. Maybe some people do it, but. Oh, okay. So I would check in with the counselor then. They must have that data on their radar. Or you could ask the teacher. Do you know the teacher? Are you going to? Yeah. They didn't email back? I'm sorry. Huh. That's annoying. Okay. All right. For the seventh period, I'll try to. I can't fix the picture, but I can fix the word to heptathlon. By the way, anyone in here in track and field? No? Anybody home? Oh. Oh, are they doing it, or but you're just not wanting to, or they're not doing it at all?
Yeah, they're doing it. I'm just not doing it this year.
Yeah, that's a real shame that it's bogus. All right. So anyway, so what guidelines do we need to follow for naming these things? I mean, you all woke up this morning wondering, hey, you know, I wonder how I can name these things. That's not true, but you do need to have these rules in order to move on. And so you want to have, you know, a memory of what happened before. You got two things. One is more positive than the other. You have the cation, then the anion. whether it's monatomic or polyatomic, doesn't matter. You have something positive, something negative for ionic compounds. But they're both going to be nonmetals in molecular compounds. If they were both metals, it would just be an alloy, and it wouldn't even be a molecular thing. So molecules are going to be just with nonmetals. Every once in a while, you'll have something that has like one metallic atom in it. But for the most part, what you're dealing with in high school chemistry, all of the molecules come from the nonmetals. And of course, none of them come from the noble gases. None of them come from the radioactive things. So you literally have like 11 atoms, 11 elements rather, that are the source of all of your molecules, which to me is pretty amazing. All the molecules around you come from a combination of just, and permutations of just 11 elements. So anyway, let's see here. So you can have lots of different combinations. Good morning. Morning, Isaac. 8:33. Anyway, and so you can make carbon monoxide. You can make carbon dioxide. If you added another oxygen, it would no longer be a molecule. It would become a polyatomic ion, CO3, 2-. It brings in those electrons with the oxygen, and so it's not a molecule anymore, although you have covalent bonds within that ion. But at least you can have carbon monoxide and carbon dioxide. So you might be able to just call them carbon oxide, you know, at first blush. But you know that this is not true. And you know that carbon dioxide it's waste for you. It's not good. You don't want to breathe too much of it. But it's not that poisonous, and it's plant food. Anything that does photosynthesis loves carbon dioxide. So please talk gently to your plants. When you do so, you waft carbon dioxide onto them. They'll grow better. Well, that's one thing that's going on a molecular physical level. Of course, another reason to talk nicely to your plants is it's good practice for talking nicely to other people. Right. If you talk nice to your plants, chances are you'll treat other people better too. But another thing too is you don't have to worry about them interrupting you. So that's kind of gratifying. But even more importantly, they've shown that even if you don't talk, if you play gentle music around them, then something about non-harsh, pleasant, at least as we define it, pleasant sound waves do cause plants to grow better. Now, I'm not going to go down that trail, but you can research that. It's a favorite science fair project. I don't think that we've had a science fair here for a while, but it is one of those things that students like to do because I mean, who doesn't want to see plants succeeding better than they are now? We're coming up to April, you know, Arbor Day and everything. So anyway, talk gently to them, talk kindly, and give them your CO2. However, carbon monoxide is not something your body produces, or if it does, it's very, very small amount, because it will take the place of O2. See, there's two atoms here about the same size as two oxygens, and it locks into your red blood cells, and it doesn't let go. The way that oxygen is let go and put into your cells, you know, for all the chemistry in your cells to happen. You studied last year in biology, right? With the electron transport chain and NADH, NADPH, and ATP. Remember ATP, right? All right. Anyway, so you've got, you don't want CO because it will not be released. And I mean, eventually it will be, but it's very easily built up in your blood. It doesn't leave your body until it's kind of forced out, like at the hospital, they can do that sort of thing. All right, so bubbles go up. And we do want to have di for carbon oxide and mono for carbon monoxide. Now, since there are two O's together, we drop one of them. We don't say monooxide or monoxide. And so there are a couple of other things you do need to do. But These are your prefixes you should know, and the higher up on the list, the more often they're used. Um, so, if you can have more than one combination, you need to use these prefixes. If there's only one particular combination possible, then no, you don't. And so, if we have, for instance, here we have carbon, right? But we don't say monocarbon monoxide and monocarbon dioxide because you never have a situation where, well, no, you never have a situation where it's like C2O. If you have carbon and oxygen together, there's always just one carbon. So you don't need, it's redundant to say monocarbon because that's all there ever is. It's just one carbon. But you could have different numbers of oxygen, so you do have to put in this prefix. All right. So anyway, prefixes in the name of binary molecular compounds tell how many atoms are present. All right. Carbon monoxide. Again, not monooxide and not monoxide, just monoxide. And then carbon dioxide. Things you've known for a long time. So, how is a triathlon different from a pentathlon? Well, what happens in a pentathlon is that's more of your typical track, throwing, running, leaping, that sort of thing. Whereas, yes, there's running in a triathlon, but you don't have bikes in a pentathlon in track and field, right? Can you imagine bikes on the track? It would be a disaster. Yeah. They do have bikes in the Olympics, but then it's just purely biking races, and those are when there's a wipeout on those, man, it's pretty nasty. Well, phosphorus trifluoride and phosphorus pentafluoride, even though they're made of the same two elements, phosphorus and fluorine, their behaviors will be quite different, quite different. Again, you have athletes in both athlons, but athlon, but they're just going to be doing different things. You don't have the same person doing both events. Of course, the simplest surface thing is the number. And that's kind of what I said. So you need to use those prefixes from up here. And if you don't know these prefixes, 7 and 9 are probably the least used. But at least know through penta. All right, mono, di, tri, tetra, penta. Tetra, you can remember like Tetris, the video game, the ancient video game, because there's always 4 squares, just different arrangements of them. Tri, it looks like 3, and so that sort of thing. Now, why don't we use bi? We use bi in chemistry for different things. So, for instance, sodium bicarbonate is hydrogen carbonate. So we already have bi being used, so we use di for 2. All right, so first of all, you have to make sure that it is actually binary. If it is multiple, then you're not going to use these things. But if you have just 2 elements, 2 kinds of elements, then you'll use that. You'll use these rules. All right, so again, sum up. You want to write the names in the order that they're listed. So it's never dioxygen carbide or dioxide carbon. That just is never done. Okay, it's always the order in the formula. Oops. And you want to make sure you have the right kinds of prefixes, not too many prefixes if you don't need them. You don't need to have mono. You don't need to have mono. So if I have water, you all know the formula for water. Please go ahead. What is the, and you don't have to put this in the chat unless you want to, okay, those of you at home. But what is obviously the name of water is water. But what is going to be the one that follows this binary molecular compound formula rules? What's the name of water going to be? That's the formula.
Hydrogen dioxide.
Hydrogen dioxide. Hydrogen dioxide. Well, how many oxygens are in there? You have to remember that in formulas, the number goes after however there many are. Like CO2, it's not C2O. So yeah, there's just one oxygen. So it'd be dihydrogen, oxide. Some people would put monoxide in there. But yes, dihydrogen monoxide. Other people would say, well, but you only have that one combination. If you add another hydrogen or take one away, then you've got an ion. And that's true. That is the only combination that is a molecule. So some people would even just say hydrogen oxide. Um, but you can look up, and there are quite a few joke scientific papers on the internet about the dangers of DHMO, this chemical that farmers spray on their crops. It's both an acid and a base. It dissolves materials very quickly and that sort of thing. Anyway, it's quite humorous. DHMO, taking advantage of the fact that most people don't know these rules you just heard about today. I think that's where we're going to stop today. Oh yes, and so please, this afternoon, you'll see some skill sheets show up. They'll be due at the end of the day tomorrow, so you'll have plenty of time to work on them, even if you don't have time today to work on them. And I hope that you have a good rest of the day. Any questions?
I have a question really quick. Oops, sorry.
Yes, Galen.
So this is what we would actually like call them, or is this what we would like write down on paper? Or is this just what, if there was asked of us, is this what we just write down?
Okay, good question. You do want to write these names. You do want to call particular chemicals these things. Now, different people, will, like if you watch PBS or whatever, the adult, not the PBS kids, but they'll say carbon dioxide or they'll say CO2. What they say out loud, and it means the same thing. But there are other more obscure things, so like dinitrogen monoxide or nitrogen monoxide or nitrogen dioxide. Those things don't get brought up as often, and so they will be written maybe with the formula, but said with these names. And so you've got to be able to use the lingo both ways. Does that make sense?
Yeah, thank you.
Yeah, thanks for asking. Let me go ahead and stop the recording.